Again, we pump up. So no C's. Okay, so that means, again, we'll get two cases. So your V will either contain A's or B's. It'll be all A's or all B's. And again, we can choose our IJs and Ks in such a way that we get a contradiction. Right? So use the reasoning of this part to solve this, and do that for homework. You do each case. Now, I'm assuming I think I've, and probably you as well. I think I understand now the mentality of Sipser and what he's letting the student work out, rather than he explaining everything. So I'll do somewhat of the same, because otherwise there are really many details. I mean, here we got like a case, a subcase, and a subcase. Right? It gets really detailed. So you do it. All right. Okay. So that's that. So even with the subcases, we've still only done case one. Now, what about case two? Case two, as in the previous example, is sort of easier. It's easier. And why is that? What is case two again? It's when your V has two or three different letters in its string, in a substring V. Now, when you do that, I'll do a blue one so if I can distinguish. Now, it's the same reasoning again, right? So if you have two or more, and let's say A and B, or A and C, or B or C, whichever, doesn't really matter. So BC, BC, let's say. So you'd have like B, C, B. So you get another B after the C. Not allowed. You've got to have all your B's before the C's, because the form of the strings that go into the language are of the form A to the N, B to the N, C to the N. Okay, so you got a contradiction. So case two is easier because they're in the wrong order for the reasons I was saying. Okay? I hope that was clear. Okay, next example. Getting very close to the end of the chapter and the end of the part one. So example 2.38, our third example. Got another language. This time we've done language B, C, now D. We use reserve A for languages in general. So these are like alternative languages. And the string, you just got to clone. You just make a copy of itself. Whatever this is, in fact, it's just a random binary string, right? Star of the binary alphabet, 0 and 1. So W is just any old bit string, just a random bit string. But whatever it is, you just clone it. So you just make two copies. You concatenate two identical copies of that random string W, right? And all such strings go into this language called the language D. And you're asked to show that that language is not context-free. Okay? And as usual, you prove that it's not context-free by proof of contradiction. You'll use the pumping lemma again. This is for our 8th time now we've done this. So you just need to find one counterexample, one string that cannot be pumped, okay, to contradict the assumption that the language D is context-free. Okay. So assume that. So yeah, assume the opposite. Assume D is context-free. Therefore, that language will have a pumping length, characteristic of the language. Call it little p as usual. Okay. Now, choosing our candidate string that we hope that we can prove is not pumpable, as usual, it's an art, so the text gives you a candidate string, and actually this one fails because you can pump it. It seemed like a good candidate, but if you divide it this way, now remember the pumping lemma says that for any string greater or equal in length to the pumping length, little p, it's possible to divide it into 5 substrings, uv, xyz, that you can pump. Now you may be able to divide it in lots of different ways, okay? But so long as just one way, I hadn't spelled that out earlier actually. So long as you can divide it, you probably can divide, obviously you can divide up the string in umpteen different ways, right? Slice it up into 5 parts. But as long as you can find one slicing, if you like, one division into the 5 parts, uv, xyz, as long as you can find one slicing that is pumpable, that's okay. Sipser didn't say that so explicitly, but I assume that's true. Okay, so here's a particular slicing up or dividing. So slice here, 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 and here. So 4 slices, 5 parts. So now if you then pump v and y, so as many times as you pump the v, like you get 0, 0, well here you get 0, 0. It's still of this form, right? Because the number of the p just goes up by 1. So that string is pumpable. So that you can divide that in such a way that it is pumpable. You can pump that as many times as you like. Say I make n copies of v here, v to the n. Well, I just have n zeros here, and remember I have to have y to the n. Well, again I just have n zeros here, and whatever number of zeros here, I add n zeros, and whatever zeros here, I add n zeros, and it's still of this form, and so it belongs to language. Therefore, it is pumpable. Right? Well, I could check the other conditions, but I assume they would work. Right? Okay, so that doesn't work. That candidate failed. So let's try another one. So how about this one? The difference being, well, they're all raised to power p. Now, obviously, if you call that w, you've got w again. So the pattern is the same, just a clone. So this string fits that description. Okay. So s belongs to this language. D is supposed, it's the nature of the proof, the start of the proof. D is supposed to be context free. Okay. Therefore, the pumping lemma applies to it, and therefore this string can be divided. Well, firstly check the length. Now the length of this thing will be 4p, it's obviously greater than p. So the pumping lemma says that you can divide this string into 5 parts, uv, xyz, such that that string, that divided string, can be pumped. Okay. Now to show that this string cannot be pumped, we're going to use condition 3 this time. Alright, and here's condition 3. Remember, a bit of a refresher. So your vxy concatenated, the size of that substring is going to be less or equal to p. So that's what we're going to try and prove that that's not the case. Okay, for a string to be pumpable, it has to satisfy all 3 conditions. It's not just enough Like the first condition is that the pump string belongs to the language, okay? But that's not enough. There are the two other conditions as well. So we'll show that this string does not satisfy this third condition, but that's the next board.